Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, so let's see who are here together with us. So good morning Gan. Waalaikumsalam Aisyah. Morning Yuhan. Morning Shamin. Good morning Zaf. Good morning Meg. Hi Pichong. Waalaikumsalam Myra. Hi Shah. Good morning Kai. Good morning Mira. Nurin, Patricia, Nob, Maisara, Andrew, Kai, Akil, Jiva, Zilong, Amanda, Aisha, Sam, and Aisha. Okay, so today we are going to finish topic 6. Okay, which is quite interesting, right? Okay, so you see we are able to finish. Okay, so 2 topics, okay, within 1 week. So I hope you can stay with me throughout the discussion. Okay, so again, and if you have any question, then you can just ask in the live chat, yeah? Okay, so today we will discuss 6.3, measures of dispersion. Okay, so let me share screen with you. So you can see here, measures of dispersion. Alright, okay, so we will cover these 3 learning outcomes. Yeah, we are going to cover these 3 learning outcomes. Okay, we are going to find and interpret variance and standard deviation for ungrouped data. And we are going to find and interpret the variance and standard deviation for group data. Okay, and we are going to find and interpret the Pearson's coefficient of skewness with this remark here. Okay, when coefficient is very close to 0, negative or positive, the distribution of data is almost symmetrical. Okay, so we'll come back to that. Okay, so but first we are going to accomplish the first learning outcome. Yeah. Okay, so we're going to find and interpret variance and standard deviation for ungrouped. And okay, why are they called measures of dispersion? Okay, now let's see. Okay, 6.3. Okay, so introduction, yeah. Okay, so 2 sets of data might have the same mean value. Okay, so in terms of the average mean, okay, they may have the same mean, but okay, they may differ in their dispersion. Okay, disperse. All right, so okay, so for example, in the following data set, so between these 2 sets, okay, A and B, so both, okay, if you try to find their means, okay, by using the formula, so we recall the formula of mean for ungrouped data. So the formula is sum of x divided by n. So if you try to find the mean using the formula, so you may notice that the mean, okay, are both 25. Okay, but most of the numbers in the first set are around the mean, you see. Okay, so this one you can see that these values here in set A, so they are in between. I mean, they are very close to 25. Okay, on the other hand, the second set is more spread. You can see here, if you try to find the difference of these, okay, individual values with the mean, you can see that the difference is quite big. Okay, so you can see that, okay, so the difference in the spread of data can be determined by the measure of dispersion. Okay, so 2 common measures of dispersion are the variance and standard deviation. So you can see here, even though set A and B, they both have the same mean, but then the data B is more dispersed than data A, yeah? Because, okay, so you can see the values of, okay, individual data here. Okay, if you try to find the difference between the data and the mean, we can see that, okay, there are quite big gaps between the values. All right, so a bigger value of variance or standard deviation means that the data are more spread out. Okay, so and less consistent. Okay, so the thing is, the bigger the variance, okay, the more spread out the data is. Okay, the more spread out the data is, and the less consistent is the data would be. Okay, less consistent. Okay, because we know that the difference between the data and the mean is going to be big. Okay, so which means we can say that the less consistent the data will be. Okay, so the bigger the variance, the lesser the consistent. All right, so now variance and standard deviation. So we do have this formula. Okay, so this is formula of variance. Okay, so you don't have to memorize this formula. Okay, it will be provided in both UPS and also assignment. Okay, and yeah, so here for ungrouped data, we do have the variance formula to be sum of x squared minus 1 over n. So by the way, n is our number of data multiplied by sum of x squared and then divided by n minus 1. Okay, and standard deviation is square root of variance. Okay, so now let's see the remarks here. If variance increases by a constant k, then the new variance is going to be k squared multiplied by original variance. And if the standard deviation increases by a constant k, then the new standard deviation, I would say, the new standard deviation, would be equal to k multiplied by original standard deviation. Okay, so now let's see example. Okay, we need to find the mean, variance, and standard deviation for the data. Okay, so you may see here the data is ungrouped. Yeah, why ungrouped? Because we can't see any intervals here. So again, the only difference between group and ungrouped data is the interval. If you have interval, then the data is grouped. If you don't have, then it is ungrouped. So now, okay, we see how many n here. 1, 2, 3, 4, 5, 6, 7. So which n equals 7? Okay, so here, so this is basically the x, yeah? Okay, the small letter x, okay? So we list down each and every data that we have, and then we square it. Okay, the square values here, the values that will help us to find the variance and standard deviation. But when it comes to the mean, we don't really need the sum of x squared. Okay, so when it comes to the mean, we just need to find the sum of x divided by the n. Okay, now because we have got the sum here, so which means, okay, you can straight away substitute the formula, okay, the value into the formula. Okay, because we know formula of mean is sum of x divided by n, right? So you can just replace the 51 here inside the formula, okay, rather than you do like this. So mean equals 2 plus 7 plus 10 plus, okay, and until the last value. Okay, so alternatively, you may just find the sum in the table and you just provide the value here, okay? All right, and then you can get the value of the mean is 7.286. Okay, now when it comes to the, okay, all right, I hope, yeah, you can hear me, okay? All right, okay, so now let's continue. Okay, so the mean is this. Okay, so now we will find the variance, okay, using the formula. So the formula of variance is this. Okay, so the formula is sum of x squared. So let's recall the formula just now. The formula is sum of x squared minus with 1 over n multiplied by sum of x squared, okay, divided by n minus 1. Okay, so now we have sum of x squared, which is 519. Okay, how can we get 519? So you just square each of the values here. 2 squared is 4, 7 squared is 49, 10 squared is 100, so on and so forth until the last value. And then you just use your calculator to find the sum of these values and you will get it to be 519. Okay, so finding the sum. So 519 minus, okay, this is sum of x, all right? Sum of x, then you need to square it, okay? And you divide by the n and then divide it by, so this is n minus 1. Okay, since n is 7, so n minus 1 is 6. Okay, so pressing calculator will give us this standard deviation value. Okay, so that is how to find variance and also standard deviation. Yeah. Okay, so it's all about substituting into the formula. Okay, so it's just about using the formula correctly. All right, so this is for ungrouped data. Okay, and let's see a second example of ungrouped data. So the following is the systolic blood pressure of 10 patients in a hospital. Okay, and then find the mean So find the mean and the standard deviation of the systolic blood pressure of the 10 patients. Okay, so how can we find the mean again? So you just find the sum. Okay, if you don't want to provide the table, no problem. Okay, because for ungroup usually we won't be given as much data. Okay, so what you can do is you just find the sum. Okay, you copy down each and every value, then divide by 10. Yeah, because in this case we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n equals 10. And in fact, it's also been given in the question, right? So we have total of 10 patients. All right, so now finding the mean, sum of x divided by the n. So this is the mean. And then standard deviation. So, okay, the formula of standard deviation again, it's sum of, okay, because yeah, standard deviation is square root of variance, right? So in order to find standard deviation, so we just put square root of x squared minus 1 over n, and then sum of x squared, yeah, divided by n minus 1. Okay, so now what you do, how do we get sum of x squared here? How do we get the values of 232, 306? Is by squaring each of this data. Yeah? You square this value, you square this, okay, until the last value here, and then you will get the value to be, okay, the value to be this. Alright, 232, 306. Okay, and yeah, we've got one question here. Okay, Nurul Najwa. Najwa asks, Madam, kalau mean tu memang kena 3 decimal places Okay, if it's not stated in the question, again, we will refer the general instruction in the question paper. Okay, the final answer may be given in the form of pi, z, fractions, or up to 3 significant figures. Okay, so the minimum decimals or the minimum significant figures that you can provide is 3. Okay, so 3 significant figures. Alright. Yeah, Mai? Okay, alright. So now let's continue. Okay, so we have got the sum of x squared, we have got the sum of x, okay, from this, okay, from the mean just now. So we can substitute into the formula, and then, okay, we divide by n here and also n minus 1 here. So this is basically the variance. Okay, because the question asks for standard deviation, so we just find the square root of that value. So we will get 14.43. Okay, so we are done with the first part of the question. Okay, now for the second part of the question says find the number of patients whose systolic blood pressures exceed 1 standard deviation above or below the mean. Okay. How do you do this? Okay, now we need to find the range, yeah? So we need to find the range. Okay, so basically this is your mean, yeah? The mean of the blood pressure, okay? So we need to find the range where, okay, the reading of the blood pressure exceed 1 standard deviation or below. So which means here we are going to add with standard deviation and we are going to subtract with 1 standard deviation. So this is basically the range that we will have. So the question says find the number of patients whose systolic blood pressure exceed 1 or below, which means we are going to find if there is any patient here whose blood pressure is outside the range. Okay, so what do we do? Okay, because the mean here is 151.8. So the mean here 151.8. So here we minus with this standard deviation to get the lower range. Okay, to get the lower reading of the range, while here we add with standard deviation to get the upper reading of the range. Okay, so we add with standard deviation. So you can see that this is actually the range that we obtain. Okay, so the range of the reading of blood pressure is between 137, okay, until 166. Okay, so now, okay, by analyzing this reading, you can, okay, so let us try to find if there is any reading which outside, okay, which located outside the range. So you can see here, okay, the lowest is 137, right? So 137 means, okay, we can identify straight away that 135 is outside the range, because it's smaller than 137. And here also 124 is also outside the range, because it's lower than 137. Okay, then what about the upper range here? So we can see that, okay, the maximum value is 166. So 166 here you can, okay, by glancing through the reading, okay, so you can see that there is one more value here which falls outside the range, because 173 is bigger than 166. So now we can, okay, finalize the number of patients with blood pressure outside the range is 3. Okay, why 3? Because of this 135, 124, and 173. Okay, so basically there are 3 patients whose readings are outside the range here. Okay, so that is how we tackle the question. Yeah. Alright, so that is about the ungrouped data. Okay, so this is example 3. Okay, the data below shows the marks obtained by Nick and Fizz in 5 quizzes. Okay, so you can see here Nick. So Nick is a very good student. He always performs. I mean, he always gets A for every quiz. While Fizz here, it's kind of inconsistent. Why? Because okay, at some point, okay, this Fizz, he didn't manage to get A, and here, okay, and then this one, so he comes to his um okay, yeah, he knows about his responsibility. So the last quiz he managed to score well. Alright. So mula-mula ni dia main game banyak. Okay, lepas tu dia perform, dia improve. Okay, and then quiz 3 dapat A, quiz 4 dapat A, and then quiz 5 dia all out, so dapatlah 98. Okay, so that is Fizz. Okay, so now based on these two sets of data, find the mean and standard deviation for the above. And okay, the question says which student shows a better overall performance. Okay, so how can we identify this student? So first we need to find the mean. Okay, so for this Nick, student, we are going to find the mean using formula. Okay, so we find the sum, then we divide by 5 because total 5 quizzes here. So we can see that the mean of Nick's mark is 81. Okay, then we have got the sum of x, and we just square each of every data, we get this value, and then from there we can find the standard deviation, okay, which is 2.24. Okay, and now for the fees, all right, so for fees here, okay, we have mean, okay, we sum the data divided by 5 as well, so we get the mean 81, okay, which is exactly the same as Nick's mean, yeah. Okay, and then okay, in order to find the standard deviation, we just use the formula. So this is the sum of x square minus sum of x, and then we square divided by n divided by n minus 1. So the standard deviation is 10. So 10.5, which is much larger, okay, much greater than Nick's standard deviation. Okay, so now by comparing, okay, so based on the question, which student shows a better overall performance? So by comparing the variance and standard deviation, so we can see that Fizz marks show a greater dispersion. Bermaksud, okay, Fizz punya ni dia lebih mencapah. Dia lebih mencapah markahnya. Okay, compared to Nick. Okay, so kalau Nick, dia lebih, okay, so the dispersion is less than Fizz. Alright, so we can conclude that Nick shows better overall performance. Okay, because you can see that, okay, you can see that this Nick's marks, okay, so the marks are very close to the mean, because the mean here is 81, right? So if we can compare each and every data here, so they are very close to the mean. Okay, so if closer the value, or the closer the data to the mean, so the less dispersed the data is, and then the more consistent the data would be. Okay, so that is how we find, okay, or how we identify which one is, okay, which student has better overall performance. Okay, so now let's discuss on how to find variance and standard deviation for group data. So we are coming to the second learning outcome to cover for today. Okay, so how to find variance and standard deviation for grouped. Okay, so the formula is not very different from the ungrouped data. It's just that we do have f of the frequency, yeah. Okay, because again the difference between group and ungrouped data is with the interval. So whenever we are given interval, so we will be given the frequencies. Okay, so that's why the formula here, okay, it does have the f letter here, okay, which represents the frequency. Okay, so now we are given here the frequency distribution table shows the masses of loaves of bread produced by a bakery. Okay, so find the mean, variance, and standard deviation. Okay, so if you can see the table here, so the table here is given, okay, so the interval here are provided in class interval. Okay, again, as what we discussed last time, whenever you are given the table, so you need to identify whether the interval is given in boundary or in class interval. Okay, so now because you can see that there is a difference here between the upper and the lower here, so we know that it is class interval. So now how can we convert to class boundary? So what you do is, you just add the upper and lower here and you divide by 2, so you will get 424.5. And here 429 plus 430 divided by 2, so you will get 429.5. Okay, so this one it will be the same value. And then next, so you just add 434 and 435, so you will get 434.5. Okay, and then next, you find 439 plus 440 divided by 2, so you will get 439.5. Okay. Alright, so now what do we do? Okay, because we get the class boundary to help us to find the midpoint, yeah. So how to find the midpoint? So you just add the lower boundary and upper boundary, then you divide by 2. Okay, so this is what we get. Okay, 4 to 2, yeah. So if you use your calculator, 419.5 plus 4 to 4.5, then divided by 2 will give you 422. And you do the same for the rest of the class, yeah. Okay, for the rest of the classes here. Okay, and then for the frequency, frequency we just copy down 16, 24, 25, 18 and 17. And if you try to find the sum, so we can see that the n is 100, or this is basically sum of f, yeah. It's either you may put the n or you can write down as sum of f, yeah, sum of the frequencies. Okay, and then we multiply the f with the x. Why? The purpose is we are going to find the mean, right? Okay, so the mean, so we need the sum of fx. So we multiply f and x, we get the product, and then we find the sum of them, so we will get this value. Okay, so I would advise you to come up, to construct this table, because you can monitor each of the values here. Okay, so that you can see that each data is written in a proper manner. Okay, so because you see, you can see clearly each data here, so that you won't miss out anything. Okay, so you just multiply f and x, and you get the product, then you find the sum, so this is the sum. Okay, and then the fx squared here will be used to find the variance. Okay, so what do we do? Okay, I need to remind you, because sometimes students, they get confused. Okay, fx squared is not equal to fx squared. So this is a reminder. Okay, so fx squared means, you need to square the x first. You need to square x first, then you multiply by x. Then multiply by f. Okay, then multiply by f. Okay, so you square the x first, like this one. Okay, you've got the midpoint right here. So these are all the values of x. So what you do, you need to square this value first, then you multiply by f. Okay, so here you need to square the 422, then you multiply by f. So this is the value that you will get. Okay, not this one, yeah. So not this square of fx. Okay, so and this won't be used in any of the formula. Okay, so this is not being used. So ini tidak digunakan langsung dalam apa-apa formula pun. Okay, so fx squared, so we will not be using this. So again, fx squared means you square the x first, then you multiply by f. Okay, so for the second here also, you square this x, then you multiply by f. Then you square this x, you multiply by f, you will get this. You square the x here, you multiply by f, you will get this one. You square this x, you square this x, you multiply by 17, you will get this value. Okay, because the numbers are big, so I won't mention each and every of them. Okay, so now what do we do? So we need to find the mean. Okay, so the first question asking us to find the mean. Okay, so the mean here is this, sum of fx divided by sum of f. So sum of fx, so we just transfer the value down, and then sum of f is 100, so we just divide. Okay, so we will get 431.8. Okay, then find the variance and standard deviation. So we just substitute into the formula. So by the way, this should be the small letter n. Okay, I would say small letter n. Okay, or this is basically the sum of f as well. Okay, so sum of fx squared, so we have got this, we substitute into the formula, and then minus with sum of fx squared. Okay, yeah, sorry, this sum of fx squared will be used in this formula here. Okay, sum of fx squared, okay, will be used, okay, let me use different ink, will be used here. While the sum of fx squared, in terms of the pronunciation, they are basically the same. Fx squared, this one is also fx squared. Okay, but then it's how you write is the different things. Okay, so because yeah, in terms of pronunciation they are basically the same, but in terms of writing they are different. Yeah. Okay, so this is fx squared, so which means we square the whole fx, so here we square it. Okay, so we bring down the value, but this fx squared will be used, okay, in this one. Okay, so I hope you can see the difference. Yeah. Okay, so here sum of fx squared, while the second one here is sum of fx squared. All right. Okay, so then we substitute into the formula, divided by n, which is 100, then n minus 1 here, 99. So you will get the variance. Okay, now looking for standard deviation, we find the square root of it, so we will get 6.63. Okay, and then, all right, so the bakery allows, okay, coming to the second part of the question, the bakery allows only loaves of bread, each with a mass of within one standard deviation from the mean, to be sold in the market. Okay, within one standard deviation. So, okay, what does it mean? So again, you have the mean here. So you have the mean. Okay, so the question says, okay, the bakery allows only loaves of bread, each of mass within one standard deviation. So within means, okay, we can add standard deviation here and we can minus standard deviation here. So this is the range that we will get. Okay, so this is the range. Okay, so the bakery only allows the bread, okay, which is between the range of this. Okay, the mean plus standard deviation and mean minus standard deviation. Why? Because here if it's too small, then okay, we will consider this bread to be too small lah. Okay, then we will not be selling them, and then this bread is considered as too big also, okay, the bakery won't be selling them. Okay, so we just take the range, okay, one standard deviation, yeah, within one standard deviation from the mean. So again, you have got your mean 431.8, and we just subtract with standard deviation and we just add with standard deviation. So this is the range that we will get. So now the question says find the interval, okay, of the bread allowed to be sold. So we have got the range. So this is basically the range. Okay, and this is the answer. Okay, so I hope it is clear enough for you to digest. Yeah. Okay, so again, if you have any question, then you can ask in the live chat. So are we okay so far? Okay, morning Jeannie. Morning Nakyu. Morning Ain. I don't know what to reply Fizan. Okay, so this one tadi soalan dah dijawab. Okay. Alright, so now let's see. Okay, the next one. Okay, next example. So the frequency distribution table shows the hourly wages of workers in a factory. Okay, find the standard deviation correct to 3 decimal places. So again, recalling the formula of standard deviation. So what do we need to have? We need to have, okay, so the formula of standard deviation. Okay, so we need to have sum of fx square, and then we have sum of fx, which will be squared here, and then divided by n minus 1. Okay, so now in order to obtain all of these, again, we require a table. Okay, so now because you see here from this, we are given the class intervals. So we change it to class boundary. So how to change to class boundary? So you just add these two, you divide by 2, you will get 7.5. Okay, and then here 10 plus 11 divided by 2, so 10.5. And then you have 13 plus 14 divided by 2, so 13.5 here. And then next 16 plus 17 divided by 2, you will get 16.5. So that is basically how to get class boundaries. Okay, now coming to the midpoint, you just add the two lower and upper boundary, divide by 2, and then the frequency is just a matter of copying down the values from the question, and then okay, finding fx. Okay, so finding fx again, so you just multiply the f with the x. Okay, so you just press calculator. So 16 times 9, 11 times 12, 8 times 15, and then 6 times 18. So you will get the fx. So then you just find the sum of them. So this is the value. Okay, then when it comes to fx square, again, you square the x first. So x square here means 6 squared, 36 times 9, you will get this value, and then 81 times 16 will give you this value, and then 144 times 11 will give you this value, and then 15 squared times 8 will give you this value, and 18 squared times 6 will give you this value. And then next, you just press calculator to find the sum, so you will get this. Okay, after we are done with the table, so now it's time to substitute all the values into the formula. Okay, so now we have sum of fx squared. So this is the value we bring down, minus with, okay, sum of fx, this value, and we need to square it. Then we divide by the n, okay, which is the sum of f basically. Okay, and then divided by n minus 1. So this is the variance that we have. Okay, now looking for standard deviation. Okay, the question says find the standard deviation correct to 3 decimal places. So we just find the square root of this value. So this is the standard deviation. Okay, why do we put the unit RM? Because here we are talking about the hourly wages, okay, of worker in a factory. Okay, so hourly wages, we are talking about the income, right? So income means, okay, so in Malaysia, the currency will be ringgit Malaysia lah. Okay, so now because it's also declared here, so it's RM. But yeah, if you don't put the unit also, not a problem. Okay, then if the manager of the factory decides to increase the wage of each worker by 20%, okay, so find the new standard deviation. Okay, so the wage or the income here, okay, the manager decides to increase, okay, so nak naikkan gaji. So find the new standard deviation. Okay, so again we come up with a new table, but this time, okay, the income will be, okay, will be added by 20%. So how do you get 20%? Okay, so which means here the difference will be with this. Okay, how do you find the 20%? Okay, so you just, okay, find the 20% of the midpoint. So in this case, okay, how to get 7.2? Because yeah, you see the total, okay, this is the previous wage plus, okay, 0.2 increase, right, of the previous wage. Okay, so what do we do here? So we will get x multiplied by 1.2 lah. So how to get 7.2? So this is basically 1.2 times 6. Okay, so if you press 1.2 times 6, you will get 7.2. And then if you press 1.2 times 9, you will get 10.8. 1.2 times 12 will give you 14.4. 1.2 times 15 will give you 18. And 1.2 times 18 will give you 21.6. Okay, so that is basically we get the increase of the wage. But then in terms of frequency, no difference. Why? Because frequency here actually represent the number of workers. Okay, so the number of workers remains the same. Okay, the only difference is with the income, right, or the wage. So we just do, okay, amendment with the wages, yeah, not the frequency. Okay, so the frequency here remain the same. Okay, so we just find the new fx and the new fx squared. So, okay, now let's see what happens to the standard deviation. So you will notice that the standard deviation will also be different. Okay, so this is the standard deviation after the increase of the wages, yeah. All right, okay, so that is it. So I hope now, okay, by now you are able to find, okay, measures of dispersion, which are variance and standard deviation for ungrouped and grouped data. Okay, now let's find the Pearson's coefficient of skewness. Okay, we discussed last time that the skewness of the data can be determined. Okay, so there are basically few things, okay, or few methods to determine the skewness. So the skewness of data, okay, based on our previous discussion, we can determine the skewness based on the values of measures of location. Okay, for example, if you have mode, okay, to be less than median, to be less than mean, Okay, and how do we identify the skewness? Okay, again, always find where the mode is, because we know mode is the measure with highest frequency, right? So the highest peak will be at mode, then going to the right. So which means it's skewed to the right. Okay, so skewed to the right. Okay, and then secondly, okay, if your mean is smaller than median and smaller than your mode, so again, we find where the mode is. And because we know mode is the measure with highest frequency, so we know that the highest peak will be at mode, so going to the left. So from here, we know that the data is skewed to the left. Okay, that is how we determine skewness from the measures of location. And not only that, okay, we also discuss on how to find the skewness based on the box and whisker plot, right? Okay, so box and whisker plot, for example, okay, if you have your box here, so which is represented by the value of Q1, Q2, and Q3 here. Okay, so we know that, okay, the peak will be at the smaller box, so we know that the data is skewed to the right. Okay, skewed to the right. Okay, and we know also all the three quartiles, okay, Q1, Q2, Q3, they also represent the measures of location, yeah. Okay, and then next, if, okay, we have Q1, okay, if the box here, okay, Q1, Q2, and Q3, so we know that the data is going to be skewed to the left, okay. So here, skewed to the left. Okay, but alright, so okay, so we can only compare based on the values. We can only compare based on the value. So okay, so far we have got two methods, okay, on how to find the skewness of data. So first, by using the mode, median, mean values, okay, and second, by using the quartile values, okay. But then the downside of this is we do not know the degree of the skewness. Okay, we do not know how skewed it is, whether it's highly skewed or moderately skewed or slightly skewed, because we cannot tell exactly from these measures. Okay, so that is why we do have the third method to find the skewness. Okay, so this is the third method to determine the skewness of data. Okay, because we have got a formula, okay, Pearson's coefficient of skewness. So we do have the two formula here. Okay, so the symbol of Pearson's coefficient of skewness is represented by this SK. Okay, so this SK represents the Pearson's coefficient of skewness. So we do have two formula for it. It's either you use the formula 3 multiplied by mean minus median divided by standard deviation, or mean minus mode divided by standard deviation. You may use any of the formula. You don't really have to provide both. Okay, depends on what measures you have at the moment. Okay, so now you can see that, okay, if the value of the Pearson's coefficient is less than 0, okay, or negative, we can say that it is negatively skewed. And if the coefficient is positive, then we can say that the data is positively skewed. And if the coefficient is equal to 0, then we can say that the data is symmetrical. Okay, and we can also tell you the degree of the skewness based on the values. Okay, so we'll see here, if the values fall in between this range, we can say that the data is moderately skewed. Okay, and again here, moderately skewed. Okay, and yeah, if it's negative, we can say that it is moderately skewed to the left. Here you can add on here to the left. Okay, we can add the direction because it's negative. And then this one also highly skewed to the left. Okay, you need to mention the direction as well. And because it's positive here, we can say that, okay, the data is moderately skewed to the right. Okay, because, okay, the value is positive. And this one also highly skewed to the right. Okay, so now, okay, let's see example. Okay, given the following sorted data, okay, so you if you notice, the data has been sorted in ascending order. So find the mean and median, hence calculate the Pearson's coefficient of skewness. Okay, so mean and median, you can see here the mean is 2.48. Okay, in this solution, the answer is directly given, but you need to show the method how to find each and every measure. For example, the mean, you need to show how you use the formula sum of x divided by n. while the median, okay, you need to show how you find the S first, okay, because in this case you see, okay, 1 2 3 4 5 6 7 8 9 10, right? Okay, so now our n is 10. Okay, so let's recall how to find median for ungrouped data. So we find the S first, right? Last time, half times 10, you get 5. And because 5 is element of integer, so which means your median is located in between the 5th observation and the 6th observation, right? Okay, and you divide by 2. So how do we get 2.45 here? Actually, we just sum the 5th and 6th. So 1, 2, 3, 4, 5. Okay, so 6. So 2.4 plus 2.5 divided by 2. So that's why we get 2.45. Yeah. So okay, you need to show clearly how you get those measures. You cannot simply straight away give the final answers. Okay, and then mode for ungrouped data, okay, is basically, okay, obtained from the data which appears the most lah, okay, which appears most frequently. Okay, so you can see here because 2.4 appears twice, so we can conclude that the mode is 2.4. Okay, and then finding the standard deviation as, so you need to show also how you use the formula. So the formula is again, okay, standard deviation, the formula is sum of x squared minus 1 over n multiplied by sum of x squared divided by n minus 1. Okay, and this is how we obtain the standard deviation value, and then hence calculate the Pearson's coefficient of skewness. Okay, so now because, okay, even though the question only asks us to find mean and median, but yeah, because the mode can be obtained directly from the data, right? So we just find the value. Okay, now you can see that, okay, the Pearson's coefficient of skewness can be obtained using two different formula. First is either 3 times mean minus median. So our mean is 2.48, our median is 2.45, and you divide by the standard deviation. So this is the Pearson's coefficient of skewness. Or, okay, using the second formula, mean minus mode divided by standard deviation. So this is our mean, and our mode is 2.4 divided by standard deviation. So this is the answer. Okay, you may notice that in terms of values, they may not be the same. Okay, the two values of Pearson's coefficient of skewness, they may not be the same, and in fact they must not be the same. Okay, because here we use this formula based on the measures mean and median, while here we use different measure, right, mean and mode. Okay, so for sure the values are going to be different, but they both will fall into the same category. So in this case, if you try to have a look at these two values, both of them actually fall into this one. Yeah, okay, so then let's say if the question asks you to interpret the data, so we can say that our data is, okay, let's say like if the question asks for interpretation, so we can say that the data is slightly skewed to the right. Okay, why to the right? Because the value here is positive, right? Okay, slightly skewed to the right. Okay, we only give this conclusion if the question asks for interpretation lah. If they don't ask for interpretation, then we don't really have to give lah. Okay, so now that is how we do it. Alright, so this is for ungrouped data. Okay, so this is basically the third method on how to find the skewness of data using Pearson's coefficient of skewness. Yeah. Okay, so now let's see second example, which is the last one for today. Okay, so example 2. Okay, this is for group data. So the time in minutes used by 120 students surfing the internet to perform a certain project is given by, okay, is given in the following relative cumulative frequency table. Okay, now you can see the word relative cumulative frequency. Okay, the idea is we are given 120 students. But now, when it comes to the cumulative frequency, okay, you see the final value is 1. Okay, why does this happen? Because of the word relative. Relative means, okay, this relative cumulative frequency is relatively to the cumulative frequency lah. So now how can we obtain the cumulative frequency? Okay, for each and every value here, you just multiply by 120. Okay, why 120? Because of the n. So this is basically the n. So it depends on the value of n that we are provided with. Okay, so if you are given n 120, so we just multiply by 120 lah. So once you multiply by 120, you will see that, okay, you will obtain the cumulative frequency. Okay, so for example here, 3 over 40 multiplied by 120 is 9. And then 19 over 60 multiplied by 120 is 38. And then 2 over 3 times 120 is 80. 53 over 60 times 120 is 106. And 1 multiplied by 120 is 120 itself. Okay, and you see this is cumulative frequency. Cumulative frequency. Okay, and then from cumulative frequency, how can we obtain the frequency? So here you just copy down. For the 9 here, you just copy down. Okay, in order to obtain the 9 here, okay, you just copy down. But now how to get 29? So 38 minus 9 will be 29. And then 80 minus 38 will give you 42. 106 minus 80 will give you 26. 120 minus 106 will give you 14. And then if you try to sum this all, you will notice that you will get exactly the value here, 120. Yeah? Okay, so for sure the sum of the frequency has to be 120. Why? Because this is actually the end that we have. If let's say you don't get 120, that means there must be something wrong somewhere. So that is basically how to check whether your table is correct or not. Okay, then how can we obtain the x? Okay, because our data here given, okay, you see the data here is given in this kind of representation. Okay, so how do we identify whether this is class boundary or class interval? Okay, so whenever you are given in this form, it is always in class boundary. Why? Okay, because you can simply use this value and you bring it down. Okay, so it will be 20 minus 40 and then you bring the 40 down. So it's 40 until 60 and here you bring it down, it's 60 until 80 and then it's 80 until 100. Okay, and okay, for the first class here, I remove because the cumulative frequency is 0. So it will, okay, so that means the data is no longer exist. Alright, so we just exclude the first class. Yeah, so we can simply continue with this. Okay, we just copy down. So 0, so we begin with 0 until 20 lah. Okay, so 0 until 20. Okay, so we just begin with this class. Alright. Okay, and then the x, how to obtain the x is just a midpoint, right? So 0 plus 20 divided by 2, 10, 20 plus 40 divided by 2, 30, 40 plus 60 divided by 2, 50, so on and so forth. Okay, and then finding the fx. Okay, so you have got your f, you have got your x, then you just multiply, and then you will get these values. And then you find the sum, you will get this. Okay, and then again, fx squared is about squaring the x first, then multiplied by f. Squaring 30 here, multiplied by 29, you will get this. Squaring 50 multiplied by 42 will give you this. Squaring 70 multiplied by 26 will give you this. And squaring 90 multiplied by 14 will give you this value. And then you just find the sum all of this, and you will get this answer. Okay, now the question says find the median and mean. Okay, so let's recall the formula of median for group data. How can we find median for group data? So we will be using the formula of percentile, right? So the formula, okay, let's recall the formula of percentile. Okay, so the formula of percentile is this. So PK equals LK plus, okay, so K over 100 times N minus with capital F K minus 1, where this is cumulative frequency of the class before divided by frequency of the class multiplied by class width. Okay, where the L here is the lower boundary. Okay, and K depending on the measure that we are looking. Okay, so if we are looking for median, so in this case, because it's located in the middle, right? So median is equal to 50th percentile. So in this case, we know that K is 50 lah. So K is 50, so 50 over 100 times 120 lah, 120 here. So now we determine the location, yeah. So 120 times, 1 over 2 times 120 will give us 60, right? So we know that the median is located in the 60th observation. So where can we see the 60th observation? We look at the cumulative frequency. Where is the 60 located? So we know that 60 is greater than 38 and less than 80, right? So we know that 60 is located here. Okay, so which means we can, okay, because 60 is located here, okay, so we know that this is going to be our median class. Okay, and straight away from here you can find your lower boundary lah. So this is the lower boundary of the median class. plus with, okay, so half times n minus, okay, 38 is the cumulative frequency of the class before divided by frequency of the median class 42 and then multiply by the class width. How to find class width? So it's the upper boundary minus smaller boundary. Okay, upper boundary minus lower boundary, you will get 20 and then you just press calculator. So this is the value of the median. Okay, and then how to find the mean? So you just use formula sum of fx. Sum of fx divided by sum of f. So 6140 divided by 120, you will get this mean. Okay, and then find the Pearson coefficient of skewness and comment on the value obtained. So by using the formula, so this is for the B part, yeah. This is for the A part. Okay, so we just use the formula 3 times mean minus median divided by standard deviation. Okay, so here, how do we get this standard deviation value? By using the formula lah. Okay, so the formula of standard deviation is square root of sum of fx squared minus 1 over n times sum of fx squared divided by n minus 1. Okay, substituting all these values, okay, into the formula will give us this standard deviation value. And then we substitute into the formula of Pearson's coefficient of skewness. And okay, you will notice that the value is 0.0933. Again, we give the value correct to 3 significant figures, yeah. Okay, and then the question says comment on the value obtained. So comment means, okay, because it falls into, okay, 0.09, yeah, 0.09 means it falls into this. Okay, 0.09 is located here lah. 0.09, right? It is still okay, it is still less than 0.5. So we can say that it is slightly skewed to the right. Okay. So we just mentioned it is slightly skewed to the right, or you can conclude it is almost symmetrical. Okay. So that is basically we determine the skewness of the data, alright, using Pearson's coefficient of skewness. Okay, so now if we look at the summary, okay, so again, okay, you can use the summary here to guide you to, okay, to help you to solve the problem lah. Okay, so you can find the formula of variance for both group and ungrouped data, and you can find the Pearson's coefficient of skewness here. Okay, and this is the formula here applicable for both group and ungrouped data, yeah. Okay, and then okay, this is the, okay, the degree of the skewness. Now how do we identify whether it's highly skewed or moderately skewed or slightly skewed? So it depends on the range here. So you can refer this reading. Okay, so if you have the value to be in between 0.5 and 1, let's say, you can comment that the data is moderately skewed to the right. Okay, so this is basically the summary of what we had discussed today. Yeah? So this is what we have covered for today. Okay, so it's now 5 minutes to 11 o'clock. So far, any question? Okay, Jiva, okay. Alright, Izazi also okay. So, no question, okay, because yeah, this topic is not that hard. Okay, it's just about using the formula needed. Okay, and this topic will be covered in UPS and group assignment, yeah. Okay, so since there is no question here, okay, so and time is about to finish, so I will stop the lecture. Okay, so thank you guys for your presence and for your attention. So I will see you later. Okay, so till then, Assalamualaikum warahmatullahi wabarakatuh and have a nice day.